My research is still on artificial intelligence, so trying to make computers act in a more humanly intelligent way, and specifically on machine learning, so trying to write programs that can learn from experience. And we then apply those, at the moment, typically within the realm of biochemistry. Before that, we were doing a lot of work on drug design, and hence the connections with the pharmaceutical industry. So we were trying to write programs that could learn by looking at existing knowledge about what chemicals have particular interesting properties, like, for instance, they're not toxic, or that they can cross the barrier between your blood and your brain, which is pretty useful, for instance, if you want to design an antidepressant. So we were looking at software that could learn to recognize those particular kinds of traits in chemicals. And the idea then is that you invent some new chemicals, like thousands of them, and just put them through your software and see if anything is predicted to have the properties you want. But more recently, we work with biochemists, again with similar aims in mind, of understanding disease mechanism and potentially developing treatments. And for that, we're interested in working out where inside a cell proteins are at a particular point in the development of the cell. And that's traditionally been done experimentally, and that's time-consuming and difficult, but gets you some data. And we've now been looking at using large quantities of data of dubious quality, which we can easily pull from the internet, and trying to use that to augment the good experimental data to try and get a better prediction of where a particular protein might be at a particular time. So in a nutshell, it's artificial intelligence, trying to make software that learns, and fairly specifically applied to biochemistry and pharmaceuticals.